Hello everyone, my name is Sabir. Today let's discuss about LSTMs. Now first of all, what exactly is an LSTM? LSTM is a language model. What exactly is a language model? A language model is basically a model that learns language. Well, it sounds like a definition that I would give in an engineering viva, but in a broader sense, that is exactly what it does. Now, the goal for us to have a language model is that imagine there is a computer. It's a beautiful machine which has changed the human life in so many different ways. Now, our objective here is that we want to teach this thing language, any language, specifically English language. Now, how do I teach this model a language? Now, in a sense, if you try and understand how did human communication start and how did people actually invent language and how did all this process of communication begin. Now, let us imagine a scenario. You are having a conversation with a person, and now how do you know that what you're speaking is actually understood by this person? How do you know that what you have said is something that this person has comprehended and is taking action in accordance with that? You only do that in a way if you have asked him something, you've given him some input, and at the same time, there's a certain expectation that you have about what the response of that person will be like. In a sense, if you think, now imagine if you're writing an examination, an engineering or a school examination, and if the question is define what a transformer is like, you won't go and write a Rajnikant story. Or if somebody asks me what the time is, I won't just respond that Jab Tak Hai Jaan is a very beautiful movie. That person would be shocked. So when you to fundamentally understand, if you're having a conversation with a person, if you want to know if that person has actually understood what you're trying to say, what you mean and what your intentions are, you can actually gauge that if that person has given certain, if his response is in coherence with what your expectation is. I mean, if you ask a person for directions, he just can't start replying back to you in a rap song. He'll have to give you directions. If you understand what I mean, just take a moment to think about it. Any conversation that you have, just pay a mindful attention to any conversation that you are having, any question that you ask, any sentence that you start speaking with somebody else. There's a certain expectation about how the response will look like, at least a broader semantic of how the response will look like. So, of all the many topics that you can speak, of that person can actually speak, there's only a small subset in which the response is actually like. And if you've actually gotten that response, then probably you can say that yes, this person has actually understood what I'm trying to say. And that exactly is what a language model is. A language model is basically a methodology. It's basically a methodology to assess if my computer has actually understood what I'm trying to say to it, what I'm trying to, I'm trying to communicate with it, and if it is in a state of understanding what I'm trying to say. That is probably what a language model is. Now, you all know what a language model kind of looks like. It's basically, some say in a very, a layman's definition of a language model is that it's basically fill in the blanks. You are given a set of words, and based on that, you will have to predict what the next word is. It is kind of true. Very raw examples of a language model is right something that you use in your smartphone. When you're typing, the words are being predicted. Your Google search, for that matter, is a language model. You type in something and it will try to predict the next words that you're probably going to type. So it can be something like the weather today. The weather today is blank. Now there are not n number of possibilities. There are only a limited set of possibilities which can actually fill this blank of all the 20,000 odd English words that are present in the English thesaurus. It can be lovely, it can be horrible, it can be awful, it can be beautiful, but it can't be a BMW, it can't be chill, it can be chill, it can't be a BMW, it can't be, I'm not getting a few examples, but you get the point. It can't be something other than an adverb that actually describes the weather. So, of 20,000 words, a good language model actually predicts a few subset of words that would make sense in this English language. Now, if I give this language model these words, it should say it's lovely or it's awful or it's horrible. It shouldn't say that the present, the weather today is a seashell, the weather today is fish or is cat. It doesn't make any sense. So that is the basic function of a language model, a good language model. So as I said before, how do you know if a person actually understands what you're trying to say? It is only when you get a response that that is something that you're expecting. So I'm not expecting the weather today is fish. I'm expecting the weather today is either lovely or horrible or awful or beautiful, but I'm not expecting something that is so far off. That basically is a language model. Now, so what is an LSTM? An LSTM is basically a language model. So if I give this sentence to my LSTM, it should predict this word. It shouldn't predict fish, but it should say predict beautiful. So if I give these 1, 2, 3, 4 words, if I give these 4 words to my LSTM, it should predict the next word. And after this, and how many number of words we want, we'll have to predict this. Now there's one thing that it is that is worth observing, that language model was present much before the advance of neural networks. Neural networks came into limelight and people started celebrating neural networks after 2012, after AlexNet, where Jeffrey Hinton and team, Dr. Hinton's team actually broke all the records and people began to notice. And that is when I think AI winter actually truly ended. Till then, people wouldn't give artificial intelligence or neural networks that importance. It wouldn't be considered a very relevant field of computer science, because the idea of neural networks is not new. It's back in 1950s that the idea of perceptron and all had actually been conceived, and RNNs were first introduced in 1986, and LSTM is not a new idea. LSTM was first spoken about in 1997. So only after AlexNet, people started actually applying these algorithms that were already present for these applications, for sentiment classification, for language modeling, to understand language. It is only because the hardware had caught up. Now there was viable, affordable computer hardware that could support these algorithms in our objectives. There were other techniques like bag of words and n-grams that were used for language modeling, and although they were not they would get the job done, but neural networks had brought in a very good amount of efficiency and precision into language models. So with the entrance of neural networks into language modeling, language models became a lot better. So what do I mean by language models became a lot better? What am I implying? When neural networks came into picture, computers started understanding language a lot more better. So that is actually the beauty of artificial intelligence. You were able to teach a computer language. So this is again an abstract sense of what I'm trying to say. So uh, let's begin with this. Okay, I'm reminded of one application that's completely off the topic. It's worth noting that I've heard this anecdote somewhere. It was a long while ago when I saw this on YouTube. I'm not sure if this is present now. You can correct me if I'm factually wrong on this. But there was a secret team for iPhone building. You can check it out. Steve Jobs had a secret team where people would there was a super secret team and that was asked to design the iPhone, and that team, the iPhone was working great. It was the first company to patent multi-touch gesture, and they wanted something radically different that was not present in the market. And Steve Jobs had, you know well, that's the story of iPhone. But the team hit a bottleneck in keyboards. They were reasonably doing well in all the departments were doing reasonably well, but the keyboard department was horrendously suffering. And the keyboard just wouldn't listen. If you type A, it would type C, and it wasn't there at all. And it came to a point, if I recall correctly, that the project had to be scrapped if the keyboard wasn't working, because that was the whole point of Steve Jobs' presentation, where it's get rid of those ugly BlackBerry keyboards and build an inbuilt keyboard. So all of Apple's engineers were called out into a room, and they were given this single task of building a touchscreen keyboard. And all the senior management of Apple arrived on the day of presentations, and individual engineers started giving out their solutions and started demonstrating things. And one after the others, all the solutions started failing. But suddenly, a junior engineer, if I'm not mistaken, his keyboard was working flawlessly, and people were, they went mad. I mean, uh, this was not working at all, and suddenly this started working flawlessly. I mean, not flawlessly, but it was way better than all the other presentations that they had ever seen. And they called him and they asked him, "Ki, Baba, tell me, what is it that you've done that this is working?" And he told, there's nothing that I've done. I've come up with this idea where I start predicting words that are likely to come. In a sense, if somebody has typed T and H, it's more likely that he will use the word E. Or if it is APPL, it is more likely that the next character would be E. So it's a character level language modeling, but it's definitely an interesting story. Do check it out when you're free. Uh, so let's begin with LSTMs. How exactly are they predicting the next word? How exactly do they know what word should come next? Now, before we start, uh, I've learned most of these things. I've taken a few resources from CS224N. Uh, this is a Stanford lecture on natural language processing. It's a very good lecture that you need to check out, and it's a series of lectures. And for LSTM specifically, do check out Cola on GitHub, cola.io. I'll put these links in the descriptions, and also please do check out a very beautiful blog written by my colleague and mentor Balaji. I just had a superficial understanding of LSTM. He's the one who actually sat me down and explained the finer details to me. So I'll post that link in the description as well. Please do check it out. And so let's begin with LSTM. Okay, now that we know what a language model is, we also know what our task quite clear is. But first, let us understand, neural networks for language modeling. The first algorithm that came out was an RNN, a recurrent neural network. Now, what exactly is a recurrent neural network? It is something that I'll post in another video, but I'm assuming that you guys have at least a faint idea about how an RNN works. So, if not, then please do check that out, and then please visit this video. Now, RNN had two flaws. One was explosive gradients, and another was gradient, and another was vanishing gradients. Explosive gradient was something that was fixed. People could fix with gradient clipping, but vanishing gradient was a big problem. People were not able to, find a solution. How do you deal with this problem of vanishing gradient? Now I'll post, as I said, I'll post another video explaining the finer details of what exactly a vanishing gradient is and what is the impact that it will have on language modeling. But to give you a rough idea, to give you a layman's idea about what this vanishing gradient is about. So as I said, the purpose of a language model is for us to be able to teach this computer the ability to learn. Now, because of RNN, and this RNN, and specifically because of vanishing gradient, what happens is our computer becomes Gajini. Yeah, you heard that right, Gajini. It's an Indian movie. People in India from both the north and the south would be aware of this, and for people not from India, it is this movie is the remake of Christopher Nolan's Memento. So, what does the character, the protagonist in that movie suffers from? He suffers from something called as short-term memory loss. It's so ironically, even LSTM is long short-term memory. So it's something like that. Our computer also becomes something like this. What I mean by that is, if I'm typing something, it will forget the previous words. If I say BMW makes the world's finest dash. So when I'm speaking to my computer and I'm trying to tell my computer that, look boss, BMW makes the world's finest cars, it will forget when I'm, first it will listen. Even we humans listen to our conversation word by word. When I say BMW, it will first hear BMW, then it will hear makes, then world's, then finest. Now what will happen is, as a human, think about it. Just hit the pause button, think about it. We as humans, when somebody is speaking with us, have the ability to process all of this information. We can hold all of this information, and I can store this context, world's finest. If I ask you, BMW makes the world's finest dash, you can say cars, you can say bikes, but you know that I'm speaking about BMW. What happens because of vanishing gradient is, by the time computer comes here, it will forget what am I talking about. It will see world's finest dash. It can say books, it can say pasta. What's another famous German thing? It can also say cat. But it will forget BMW. It does not remember that the first word that I spoke to it was a BMW. So that exactly is what vanishing gradient does. And this is not a computer with which I would want to have a conversation with, because it will not understand most of the things that I'm speaking with it. If I cannot have my computer have a decent conversation, would you want to have a conversation with Gajini? I mean, just imagine, how difficult would it be for, to speak with him, to try and understand him. Imagine you're giving him, a presentation, and at the end of the presentation he asks, okay boss, it was all great, but what exactly were you giving, what was the topic of this presentation? So you wouldn't want your computer to say that. So that is the reason to address this problem. How do I ensure that my computer knows I'm talking about BMW? it understands that okay, this is what I'm talking about. It is able to remember all of this context, process all of this information together, make some meaning out of it. To address this problem exactly, LSTMs were introduced. Now, how exactly LSTMs do that? Uh, let's check it out.